Good morning, everyone. Today we shall see what are collections, inheritance, these things in RDF schema. Collections. A collection is considered to be a fine grouping of items for a given terminator. Within RDF, a collection is defined through the use of RDF colon parts type is equal to collection and through listing the collected resources within the collection block. Next, reification. The RDF allows us to make statements about statements using a reification mechanism. This is particularly useful to describe belief or trust in other statements. This example discuss the interpretation of multiple statements in relationship to RDF statements. Okay. Let's start with the 5 simple facts that we wish to represent as a RDF triplets. Okay, first one, the name of the URI Hofstadter at yahoo.com is Douglas R. Hofstadter. The type of this URI is a person. The author of the URI is ISBN number. The ID of this URI is book. The title of this URI, that is ISBN number, is golden Easter and external golden braid. Or alternatively, you can write these things as URI mail to Hofstadter at yahoo.com is the name Douglas R. Hofstadter. This URI is type of person. This URI is an author of book with that ISBN number. This is the identity of the book. And URI has a title, An Eternal Golden Braid. We can represent these 5 facts as RDF triplet as shown in the table. Subject is nothing but mail to Hofstadter at yahoo.com. Predicate is name. Object is nothing but Douglas R. Hofstadter. Next predicate is type. Object is person. And next predicate is author. Object is ISBN number. Predicate is again type. Object is book. Predicate is title. Object is nothing but name of the book. The information like the table can be illustrated in the graph form. The simple RDF statement is divided into 5 directed graphs. First one, same thing. What was there in the table? It is represented in the form of a graph, directed graph. Hofstadter at yahoo.com. Name, arrow mark indicates the predicate. Direction, edge name, and from here to here it is represented. Name Douglas V. Hofstadter. Type person, author with this number, type book, title this title. Same table format is represented in the graph. And then we can merge that graph. Individual triplet statement can be merged into a single graph like this. Mail to Hofstadter at yahoo.com. Its type is person, name is Douglas Hofstadter, and author of the book number, ISBN number. This number type is book, and its title is An Eternal Golden Braid. See, RDF statement, a statement can be given and you may be asked to represent it in the graph form, triplet format, and this RDF graph also it may be asked to write. It will be a very simple. Only thing is you have to identify the subject, predicate, and type. Okay. Type Hofstadter type person name, and again same author of this ISBN book number, type book title, this title. The serialized form of RDF document for the above previous example can be written as okay, it can be written as like this: XML version, RDF ID. I will write it as book, and then you write its URL. Title you can write. Okay, class has begun here. End the class. Okay. Um, Same thing in the serialized form. You can write that as follows. Next, RDF schema. The RDF provides a simple and powerful model for describing information, including a basic directed graph. But the semantics, that is meaning of the information, is described using RDF. Yes, that is nothing but RDF schema. The purpose of RDF is to provide an XML vocabulary that can express classes and their subclass relationship, as well as to define properties associated with classes. The RDF schema are focused on defining taxonomies, that is class hierarchies, that in turn facilitate inference and search. The schema is actually a primitive ontology language, okay, which we will see in the upcoming classes. So what are classes and properties? To describe a specific domain, we specify the things we want to talk about. We can talk about either individual objects, resources, or classes that define types of objects. A class can be considered as a set of elements. Individual objects that belongs to a class are instances of the class. The relationship between instances and classes in RDF is expressed by RDF type. An important here, it will be represented like this. An important use of classes is to restrict what can be stated in an RDF document using schema. When a relationship exists between two things, we can express it as a class. The subject of any property is a domain of the property. The object of the class is called the range of the property. A property can have many domains and ranges. The three most important RDF concepts are resources, class, and property. Resources means RDF S colon resource, RDF S colon class, RDF colon property. These are all classes. Class in the RDF S namespace. Property is in the RDF namespace. For example, all terms in RDFs are types of resources. We use the RDF colon type property to declare that something is a type of something else, as following. Like here you can see here RDFS resource, RDF type, RDFS class. Okay, RDFS class, RDF type, RDFS class, RDF property, RDF type, okay, RDFS class, RDF type, RDF type of RDF property. This means that resource is a type of class. Class is a resource is a type of class. Class again is a type of class. Property is a type of class, and type is a type of property. Okay. For example, the RDF :id provides a name for the class. Okay. Name for the class, and the conjunction and of two subclass of statements is a subset of the intersection of the classes. Okay, RDF class, RDF ID is equal to set1 and set2, and provides a conjunction of these two statements. Okay. The table here represents RDF and RDF classes. Okay, RDFS resource, class of all resources. RDF literal, class of all literals. Okay, XML literal RDF, the class of XML literals. RDFS class means class of all classes. RDF property means class of all properties. RDF data type means class of data types. Okay, RDF bag means an unordered collection. ACQ means an ordered collection. Okay, difference between bag and ACQ. ALT means a collection of alternatives. RDF container means this container. This represents a set of containers. Okay, the container membership properties. List means RDF list. This table represents RDF and RDF's properties. Okay, RDF type, a related resource to its class. Subclass indicates a membership of the class. Subproperty indicates specialization of properties. Domain, what domain this class of type. Range, class for a property type. Label, provides a human readable version of a source name. Comment, use this for description. Member of a container. Okay, first item in the RDF list. Rest of RDF list after the first item. See also a resource that provides more information is defined by indicates the namespace of the resource. Value identifies a principal value. Subject, the subject of a RDF statement. Predicate of an RDF statement. Object of the RDF statement. Inheritance. Once classes are established, the relationship between them must be established through subclasses, superclasses, and so on, which is nothing but inheritance. Suppose we have the following related classes for polygon that are plane figures with 3 or more sides. Okay, then we have to, how we can establish the inheritance relationship for these things. Okay, we know that all quadrilaterals are polygons. All polygons are shapes. Squares are nothing but quadrilaterals. In predicate logic, simple related classes can be represented as, okay, quadrilateral of X is nothing but polygon of X. It will be represented like this. Polygon of X is nothing but shape of X. Quadrilaterals are nothing but squares. And now from the knowledge, the following conclusions can be deduced. Okay, polygons are nothing, okay, squares are nothing but polygon. Shapes, squares are nothing but shapes. Okay, we are deducing the relationship. Quadrilaterals of X are nothing but the shapes. Okay, the hierarchy relationship of the same is shown here of the following shapes. Which shape can be a circle, polygon, lines. Okay, polygon means it can be a triangle, quadrilateral, or any other polygons. Hierarchy of class. Consider the range restriction that organization charts can only include quadrilateral, and suppose that we want to use squares in an organization chart application. Our restriction actually prohibits squares from being used. The reason is because there is no statement specifying that square are also a member of the polygon class. What we need is a square to inherit the ability to use the class of polygons. This is accomplished through RDF schema. The RDF schema fixes the semantics of is a subclass of. Now the meaning can be used to process software. As a result, RDF schema is a primitive ontology language. Object-oriented programming also uses classes, inheritance, and properties. However, in RDF schema, properties are defined globally, and it is possible to define new properties that apply to an existing class without changing that class. RDF and RDFS layers. Consider the RDF statement. Nuclear physics is taught by Professor Smith. Okay, see the diagram. The schema for this contains classes and properties, which separates the layers of RDF and RDFS. Okay, this bottom layer is RDF and this above is RDFS. This is nothing but nuclear physics taught by Professor Smith. Okay, that is RDF. Now let us consider the following classes: academic staff and courses. Okay. If course C is taught by academic staff A, then C also involves A. We can consider the class academic staff having subclasses: professor, okay, associate professor, and assistant professor, okay, subclasses. In addition, property hierarchies consider it's taught by is a subproperty of involves. Okay. So the blocks are in the figure. You can see the blocks are properties. Ellipses in the RDF layers represent classes. Okay, these are classes, and this is property. Okay, in RDF layer, these ellipses represent instances. The RDFS is therefore able to express the ingredient, subclass, class, property, subproperty of resources, and so on. Okay, all these things were able to represent this. Okay, constraints on properties. The constraints on properties are introduced through RDFS domain and RDFS range. The property RDFS domain restricts the set of resources that may have a given property, that is domain. The RDFS range property restricts the set of values for a given property, that is the range. The domain and range force subjects and objects of a property to be a certain type. Okay, so this diagram shows the relationship between primitives in RDFS. Okay, resource, RDFS property, okay, constraint property, constraint resource, property resource, and RDFS class. RDF and RDFS limitations. The RDF uses only binary properties. This restriction is important because we often use predicates with two or more arguments. Fortunately, RDF allows such predicates to be simulated. Another RDF limitation results from properties as special kinds of resources. The properties themselves can be used as the object in an object attribute value statement. This flexibility can lead to modelers becoming confused. Also, the reification mechanism is very powerful but may be misplaced in the RDF language, since making statements above statement is complex. The RDF promotes the use of standardized vocabulary, standard types, classes, and standard properties, while RDF XML-based syntax is well suited for machine processing. It is not user-friendly. We can summarize like RDF is not an optimal modeling language. However, it is an accepted standard upon which subsequent ontology languages can be built. Okay. That's all about RDF schema. All of you like mark your attendance. From tomorrow we shall see ontology web language. Thank you. Please mark your attendance.